Greetings, this is part 3 of my frequently asked questions for week 2. I got a question from one of you that said, how do vectors and planes and points all work together? That was a common theme in several of the questions this week. It sounded like there were many of you who wanted to know more about how normal vectors to planes work and how the equations correspond to those. So let's take a look at a very generic problem that I put on the board here. I've drawn a plane which goes through some point x0, y0, z0. We don't know what it is exactly, and has some normal vector ai plus bj plus ck, which is perpendicular to the plane. Now, when you did problem 1 in the workshop last week, I had you develop a test for when a certain vector is in the plane. Now, if I have some point, let's call it x, and its coordinates x, y, and z. Actually, let's not use x because that's too easy to confuse with lowercase x. Let's call that w. There we go. I have some point, w equals x, y, and z, and I want to have a test, a reliable test, for whether that point's in the plane. The way that I do that is by looking at the vector from p to w, or pw, and determining whether that vector is perpendicular to my normal vector. Now, in this picture, it doesn't look like it because of the way the perspective is, but you'll notice that if this point really is in the plane, then this vector should be perpendicular to my normal vector. Now, first of all, let's write down what the vector pw is. Pw can be written as the point whose coordinates are the differences between coordinates of p and w. So here I have x minus x naught, y minus y naught, and z minus z naught. Actually, sorry, I don't want to put that as a point. I want that as a vector. Let's try that again. Same coordinates, but different way of writing it. X minus x naught I plus y minus y naught j plus, now I'm out of room, z minus z naught k. That's what this vector is. That's the direction that it's going. All right. Now, I want to test for whether that vector is perpendicular to this normal vector. And as you learned in class, the way that we test whether two vectors are perpendicular is by using the dot product and seeing whether it's equal to 0. So pw will be in the plane that is perpendicular to this vector here, if and only if pw dotted with this normal vector equals 0. That is, w is in plane if and only if that dot product is equal to 0. Now let's write down algebraically what it means for that dot product to be 0, because I have coordinates for n and I have coordinates for pw. N dot pw is going to be a times x minus x naught plus b y minus y naught, b times y minus y naught plus c times z minus z naught. And I need all of that to equal 0. Now you'll notice that this equation that I've written up here is very much like the one in your textbook. In fact, it should be exactly what's in your textbook, assuming I've used all the same symbols. The equation for the plane that goes through the point x0, y0, z0, and that is normal to the vector ai plus bj plus ck is a x minus x naught, b plus b, y minus y naught, plus c, z minus z naught. Again, I have my normal vector and my initial point, both represented in this formula. One thing that is conceptually a little bit tricky is that in this formula, x0, y0, and z0 are all constants. Those are some known point that my plane goes through. The only actual variables here are x, y, and z. Another thing to point out is that a, b, and c are not slopes in this case. If I had written this plane in the form z equals something times x plus something times y plus some z-intercept, then those coefficients for x and y would be slopes. But in this case, they're not. You'll notice that if I increase x by a little bit, then this component may go up, depending on whether a is positive or negative. But in order for this whole expression to remain 0, something else would have to happen to z, and what that is unknown. It's not exactly a slope, in other words. Okay, so that's one thing I wanted to answer, but there's actually another question on the same index card, which was, How do you find if two planes intersect? Let's try that. Let's do an example of that. Now, before we go on, think about how likely it is that two planes will intersect. If I just think of two random planes, like let's say this one and this one, of course they're going to intersect somewhere because they go in different directions. The only way for two planes not to intersect is if they happen to be parallel and don't contain any of the same points. Two planes could be parallel in the sense that they go the same direction and actually end up being the same plane, but even that is unlikely to happen. I'm going to write down two plane equations. 2x minus 2 plus 3y minus 1 plus 5z equals 0. And then a second plane equation, 2x plus 3y plus 5z equals 10. And we're going to investigate whether these two planes intersect or not. Now, in this case, I was very deliberate in putting up two equations for planes that have the same normal vector. In this first equation, we can immediately tell that the normal vector is 2i plus 3j plus 5k. That's my normal vector for the first one. But the second plane has the same normal vector. If I were to work out another form for this plane equation here, I could get 2x plus 3y plus 5z equals some constant. This plane is going to be parallel to that. This 10 here simply means that the plane might be situated somewhere a bit different but going in the same direction. So both of these are going to have the normal vector 2i plus 3j plus 5k. So I have two planes with the same normal vector, meaning they could potentially be parallel. But we don't know that yet because it is still possible they are the same plane. Now, if they're the same plane, then I should be able to take any point from here, and that point would have to be on this plane here. If I take a point from here and it's not on this plane, that means I have two completely separate planes and they never meet. So let's take a point that's on this plane. Can you recognize a point that's on that plane without doing any actual work? You should be able to because I put this in point normal form, meaning that 2, 1, and then 0. 2, 1, 0 is a point on this first plane. Question is whether it's on the second plane. If I substitute these coordinates into the second equation, I get 2 times 2 is 4, and then 3 times 1 is 3, and then 5 times 0 is 0. I get 2x plus 3y plus 5z equals 7, not 10. So this point here does not lie on this plane, which means that the two planes I have are parallel, but they contain completely separate points. They do not intersect. On the other hand, if I put something like a 4z here instead of a 5z, none of this point checking is necessary because I know that these two planes have different normal vectors. Even if they are a bit close together, they are different, which means that in some point in space, they have to meet. They are not parallel. I got one more question that asked, how important is it to be able to complete the square? It's actually a little bit important in this course. I would not say it's extremely important, not so much as it is in Calc 2, but you should learn how to do it because that perspective is going to come in useful when we do Chapter 14. So I would say go ahead and learn how to do that. It takes about, I don't know, depending on your learning style, may take a little while, may take as much as an hour. But there are videos, should be videos on Khan Academy that tell you how to do it. And then once you know how to do it, once you've practiced a few examples, you'll have it. And then when your professor does it in class, you'll be able to recognize what they're doing. Anyway, that's the end of the frequently asked questions for this week. Just 3, but I thought they were 3 pretty high-powered questions. I will see you in class, and I wish you the very best on your exam. I'm not going to say good luck because I don't think it should be luck. It should be that you are confident and that you know what you're doing. But I think that you'll do well, and I'll see you Wednesday.